the third method for solving a system is by graphing. And I wanted to show you how you could use your graphing calculator to find the solution to a system of equations in that way. So like examining this system, again, we have a system of two linear equations. These ones are actually both solved for y. This would actually be pretty easy to solve via either elimination or substitution. But additionally, what I wanted to go back into what I was saying is, well, those create two different lines, and we could find the answer by looking for the overlap. Um, and if we're going to be using the graphing calculator, since it's solved for y, that actually makes it quite a bit easier because most graphing calculators graph functions. So like, for example, I could just graph each equation. Um, so like I could graph 2x minus 4. And then I could also at the same time graph negative 1/2 x plus 6 and just see where it crosses. Um, and if I graph that, my viewing window is a little bit different because of my other class. So I'm going to hit zoom standard to set it back to the normal negative 10 to 10 window. But basically what I get is two different lines that have an overlap. And my answer should be exactly right there. So if I'm looking at it, it looks like it's approximately 4, 1, 2, 3, 4. It's kind of hard to tell exactly where they overlap as well. But there is a way to actually calculate it more exactly, because while in a lot of our examples the answers are nice, pretty numbers, a lot of the time systems don't overlap at exact locations. Like it could overlap at say 4.2, comma 7.9 or whatever. Um, but you can calculate this, what we call the intersection point of the two lines, with your calculator. So in a TI-84 or 83, this can be done by using the calculate menu, which is above trace. If you hit second calc, option number 5 is the option to intersect, and that's what we can use to find that point exactly, or as best as the calculator can. And if you hit that intersect command, it will ask you to then move your cursor to the point of overlap. So on the first curve, what I want to do is take my cursor and move it as close as, or close enough to that point, hit enter, then do the same thing on the second curve, get close, hit enter, and then it will ask guess. Again, you want to get as close as you can, hit enter again, and as long as you hit enter 3 times and you move it close, basically you're telling your calculator to look in this vicinity for the intersection point. If you don't move it around, it might get messed up. So you don't necessarily have to move it actually. But some systems have more than one overlapping point, and in those cases you would need to be more careful. But anyways, what we get is the intersection point is 4, 4. That's going to be the answer to our system. So basically what I would get is the solution to this system is 4, 4. I didn't have to do any algebra to find it, which I'm using my calculator's ability to do a bunch of math and figure out what those. Sorry, my mic decides to turn itself off. But to use our calculator to do all the math to find the overlap, cool. And that's totally fine. There's actually a totally different calculator method, because when we move on to more advanced systems, this method, it seems really easy, but it becomes more and more elaborate with more complex systems. And there's a completely separate matrix method of solving these, which we're going to do in chapter 6, which we'll get to later.